Imagine the universe before time and space. Silence, darkness, nothingness, no stars, no planets, no galaxies, not even the void of space itself. This was the state of existence before the Big Bang. No light, no sound, no matter. Just an infinite sea of pure potential energy. This set the stage for the birth of our universe. Within this silent void, a spark of unimaginable power was about to ignite. The universe as we know it was about to explode into being. From this silent void, the universe exploded into existence. This wasn't an explosion in the traditional sense. Imagine a single point, infinitely small and dense, suddenly bursting outward. This was the Big Bang. The universe went from being smaller than an atom to an unimaginably vast expanse. Space expanded at an incredible rate, carrying with it a soup of energy. The early universe was chaotic and violent. Temperatures were trillions of degrees. The Big Bang was the birth of space, time, and the laws of physics. Imagine a balloon with dots drawn on its surface. As you inflate the balloon, the dots move farther apart. This is a simple way to visualize the expansion of the universe after the Big Bang. Space itself stretched, carrying galaxies along for the ride. As the universe expanded, it also cooled, much like air escaping from a balloon. This cooling was crucial for the formation of matter as we know it. In the first few seconds after the Big Bang, the universe was too hot for even atoms to exist. Instead, it was filled with a sea of elementary particles, quarks, leptons, and their antimatter counterparts, colliding at unimaginable speeds. But as the universe expanded and cooled, these particles began to slow down. The universe was transitioning from a chaotic sea of energy to a more structured environment where matter could form. Section 4. From Plasma to Atoms. As the universe continued to cool, a remarkable transformation took place. The universe transitioned from a hot, dense soup of plasma to a cooler state where atoms could form. Protons and neutrons, once swirling freely, combined to form the nuclei of atoms. Electrons, no longer jostled by the intense heat, were captured by these nuclei, creating the first atoms. The formation of atoms marked a significant turning point in the early universe. Light, which had been trapped by the dense plasma, was now free to travel through space. This first light, known as the cosmic microwave background radiation, still permeates the universe today, offering a faint echo of the Big Bang. With the formation of atoms, the stage was set for the next chapter in the universe's story, the birth of stars and galaxies. Section 5. The Cosmic Dawn. Gravity, the architect of the cosmos, began to exert its influence on the newly formed atoms. Vast clouds of hydrogen and helium gas, remnants of the Big Bang, began to clump together under their own gravity. These clumps grew denser and hotter, eventually reaching temperatures and pressures high enough to ignite nuclear fusion in their cores. The first stars were born, blazing with a brilliance that pierced the darkness of the early universe. These early stars were giants, much larger and hotter than our sun. They lived short, brilliant lives, fusing hydrogen into helium and heavier elements in their cores. When these stars eventually exhausted their fuel, they exploded as supernovae, seeding the surrounding space with the building blocks of planets and life. The death throes of these early stars gave rise to a new generation of stars, including our own sun, enriching the universe with the elements necessary for life. Section 6. Our place in the cosmos. The formation of stars and galaxies marked the beginning of the universe as we know it. Over billions of years, galaxies collided and merged, shaping the large-scale structure of the cosmos. Within these galaxies, new stars continued to form, each one a potential solar system in the making. Our own solar system formed from a swirling cloud of gas and dust, a remnant of a long-dead star. As gravity pulled this material inward, it began to spin, forming a disk around the nascent sun. Within this disk, dust grains clumped together, forming larger and larger objects. Over millions of years, these clumps grew into planets, asteroids, and comets. Our Earth, a rocky planet orbiting a relatively young star, is a testament to the incredible journey the universe has taken since the Big Bang. From a silent void to a cosmos teeming with stars, galaxies, and planets, the universe continues to evolve and expand, its future still shrouded in mystery.